Number 20, we want to write the equation of the line, and it describes it as having a y-intercept at 0, 2, and parallel to the line y equals -3. Similar to the one above, these types of problems have little to no work. You can think about them. Another option would be you sketch it if you're not sure what's going on here. So 0, 2 is here. And we have a line at y equals -3. So if we want a line that's parallel to this black line has a slope of 0. So our new line also needs to have a slope of 0, which means that our new line also needs to come in the form y equals a number. And the number for this new line needs to be the height of this new line, which I'm drawing in a dashed line, which is at 2. So y equals 2 is the equation of our new line, which technically, I'm just going to change this to blue just because, this is technically both in slope-intercept form and standard form. Number 21, and the instructions for it say write the equation in standard form, show all your work. So to get to standard form, we usually need to go through slope-intercept form as we do these. So just keep in mind you're going to repeat what we did on the other problems, but maybe do some work towards the tail end to convert it into standard form. Standard form looked like this. Had no fractions and no decimals, and a had to be positive. And it had to be lockstep in that order. 21 says we want to write the equation of a line that has an x-intercept at -3, 0 and is perpendicular to the line y equals x. Well, y equals x has a slope of 1, which means that my new line is going to have perpendicular opposite reciprocal. So opposite of 1 is -1, and the reciprocal of 1 is in fact 1. That means our new slope is -1. And the fact that this is an x-intercept is cool and all, but we just have to go through the process of solving for b. So we're going to plug this into y equals mx plus b, and then we'll do some extra work to get it into standard form. So we have 0 equals -1 times -3 plus b, which is 0 equals 3 plus b. Additive inverse, move the 3 to the other side, and we get -3. Maybe over here, I will now write what I have. I have y equals -1x minus 3, and I'm going to convert this into standard form by moving x and y to the same side, getting x first, y second, and then the constant. And in fact, that meets all the requirements of standard form. Last one in this batch, number 22. We want to write the equation of a line that's parallel to this and passes through the point 1, 8. Well, parallel, that means that we're going to want to have the same slope. So for a second, I'm going to tinker with this equation and get it into slope-intercept form. So 9 halves plus 8 halves is 17 halves. All right. So next, I need to start building my new equation. My new equation, which I'll do in orange again, is going to have the same slope. And my new equation is going to go through this point. And I'm going to ignore the blue work now. All right, so we have 8, which is my y, 1/2, which is my m, 1, which is my x, And now I have my b. Next, I'm going to write this as slope-intercept, which is y equals 1/2 x plus 15 halves. And I'm going to do the work to convert this into standard. I'm going to move the x's to the same side, or excuse me, the x and the y to the same side. And I'm going to, let's think. Well, x and y are together in order, constants on the other side. I can have no fractions anywhere, so I'm going to need to multiply by 2. And I need the leading coefficient, or the coefficient of x, to be positive, so I'm going to multiply by a negative. And when I do that and I distribute, I'm going to get x, or 1x, minus 2y equals negative 15. Now, remember a way to check this. It won't be a perfect check because we technically need a couple points to check. But if we plug 1 and 8 into this, 1 minus 2 times 18, sorry, 2 times 8. Let me do that again. 1 minus 2 times 8 is 1 minus 16, which is negative 15. That is a good sign that when you plug this point in, it does check out. So remember that you do have some opportunities for checking your work.